Okay, so the product one, again, h of x is equal to f of x times g of x, right? Okay, so they'll give you an equation for f of x. What's the equation for f of x?
X plus 3.
X plus 3. So we've got a line here, right? What's the equation for g of x?
2x minus 1.
2x minus 1. So we need to show the product. So let's do this algebraically. Because when I do it algebraically, then I can see what kind of shape I'm going to end up with. All right? Because it is a line times a line. Is that going to give me a line? All right? So that's what we're trying to figure out. So let's go h of x is equal to x plus 3 times 2x minus 1. What are we going to end up with? Problem. Quadratic. Right? Okay, so I've got 2x squared. That's minus x. That's 6x. So that's plus 5x minus 3. There's your h of x. And h of x comes from the product of the two lines that we have. X plus 3 and 2x subtract 1. Okay? So again, you would draw out your lines, and then you would draw your parabola. And again, you can use your calculator to do set operation for this. All right? The quotient becomes a little bit more difficult because of one thing. And that is the quotient involves one or many non-permissible values again, depending on what the equation is on the bottom, right? So let's look at h of x is equal to f over g x, which is your quotient. So you can either write f of x over g of x or f over g of x, in which g of x cannot equal 0, right? Okay, so then f of x is 3x minus 1. G of x was x squared minus x, is that right? Okay. So then h of x then would be equal to 3x minus 1 over x squared minus x. And then we'd have to do some simplifying, and we would graph this on our calculator again. The function, or so the domain of the function, of the product, or quotient of functions, is the domain common to the original functions. So exactly the same as sums and difference, the domain value is found by what's common between them. So basically it's the lesser of the two, whichever is the smaller of the domains. Okay? The domain of a quotient function must have the restriction that the divisor cannot equal 0. That is, for h of x is equal to f of x over g of x, the values of x such that g of x cannot equal 0. In this one right here, what are your non-permissible values?
X and
So what value of x is it non-permissible?
X can equal 0.
Okay, excellent. Okay, that was well done. I didn't think you'd see that, but it is. X squared minus x can't equal 0, right? Which then means that x times x minus 1 can't equal 0. Therefore, x cannot equal 0 or 1. We have to factor the bottom. Okay, with the greatest common factor. Okay, and that's the one that would have got missed. If you had said 0, you'd have been half right. But you have to remember that with that squared value, there's always going to be some element of factoring when it comes to non-permissible values. Okay? All right, so let's look at a couple questions here. And we'll work through it in our book. F of x is equal to x minus 3. What's g of x equal, please?
X squared minus 8x plus 15.
Okay. So, it says determine h of x, which equals f of g of x, or f times g of x, and then state the domain and range. All right, so let's start with the first part. Okay, we want h of x, which is x minus 3 times x squared minus 8x plus 15. What kind of graph am I going to get out of this guy? Pardon me? Cubic, that's right. Okay, so again, grade 11 skill here, we need to multiply a binomial by a trinomial. So we can stack them, right? Or we can just multiply each value through and then collect the terms. So that's what we'll do. I'm going to times x all the way through the brackets here. That gives me x cubed minus 8x squared plus 15x. Right? Now I need to multiply the minus 3 through there. Minus 3x squared plus 24x minus 45. Okay? So I multiply x by x squared, get x cubed. X by minus 8x squared. X by 15, get 15x. Minus 3 times x squared is minus 3x squared. Minus 3 times minus 8x plus 24x. And minus 3 times 15 is negative 45. Collect the like terms. X cubed minus 11x squared plus 39x minus 45. Okay? Anybody have a question as to how we multiply that? Right? Okay, so using your workbook, it says the function f of x equals x minus 3 is linear, and the domain therefore is x and element of all reals. The function g of x is x squared minus 8x plus 15 is a quadratic. Again, the domain is x and element of all reals. Therefore, the domain for the graph is what? It's both, right? It's a combination of both of them, the smallest. Okay, without doing anything, without thinking it through, what's the domain for any cubic function? X an element of all reals. And what is the range for it? Y is an element of all reals. So as long as you know what a cubic function looks like, then you end up with the domain and the range without having to know what the domain of this or this is. Right? But it does help. Okay? Let's look at the quotient. F of x equals x minus 3. G of x is equal to x squared minus 8x plus 15. Is that the same one?
Yeah.
And we want to divide the two. So let's write it out first. H of x is equal to x minus 3 over x squared minus 8x plus 15. Okay? What's the first thing we do with any rational function? Yeah, to find what though? Let's do the non-permissibles first. So, x minus 5, x minus 3 can't equal 0, right? Therefore, x cannot equal 5 or 3 by factoring the bottom. Okay, going back to the test we just wrote. What does that tell us about the type of graph we're going to see next? Okay, let's start with that. Because I have an x minus 3 on top and x minus 3 on the bottom, what does that tell us? For me? Okay, so we have a point of discontinuity, right? At minus 3, and we'll figure it out in a second. Or sorry, plus 3, not minus. plus 3. So then we cancel that, and we end up with 1 over x minus 5. Which is what? It's not a line, it is. We know what it's called? Reciprocal. Well done. Okay? So I stick 3 in here. 3 subtract 5 is -2. So my point of discontinuity is at minus 1/2, right? Okay? What does that graph look like? There's 1 over x with asymptotes, right? Okay, and where do I move it to? For me? Right 5. So all of this goes right 5. This guy comes over here. This guy comes over here. And at 3 and -1/2, I draw my point of discontinuity. Okay? So this again is what we just finished doing yesterday. All right? Again, you have your calculator to help you. All right. That's products and quotients. All right?